welcome to Hexagon Live, the Autonomous Drill Solution Session. Thank you for taking some time today to join us. All done. Drill automation is about more than just automating a drill, right? So what we're really trying to do here is create value by solving problems. Skilled operators today, at least in the United States, are very difficult to come by. I'm sure you're seeing the same thing in other parts of the world as well. Operators are very costly to train. It takes more than 6 months to turn a new operator into someone who really knows how to drill. They can get okay at it, maybe, not make so many mistakes, but it takes years to become an expert at drilling. In fact, if you've ever read the book From Good to Great, it takes 10,000 hours to become a true expert at anything that you're doing, 10,000 hours of actually doing it. And then lastly, machine performance and hole quality. It does us no good whatsoever to drill a hole if when you come back to load it on blast day, it's no longer there. It's a big problem if you're drilling holes and they're caving in when you leave. So what does our solution look like? Hexagon's solution. So we raised the bar, and we're going to show you the results of this thing here in just a minute. We raised the bar not only for the lower operators, the newer operators, the green guys, but we raised the bar for the experts. We outperformed the best of the best, at least at this particular site. We managed to retain the OEM platforms, so we're not having to replace control systems on the OEM drills. This thing goes in parallel to the OEM drill platform. That way you don't have to worry about changing your support infrastructure, your parts support, your supply chain that you've built over decades. And then it takes 15 minutes to turn a new operator. In fact, I could take any one of you out here today, give you 15 minutes of training, and you would be the highest performing drill operator on your mine site. How did we do that? Well, we combined a few things. Hexagon is great at machine guidance. We're also good at automating equipment, as it turns out. So we take the Hexagon machine guidance layer, which is the high precision GPS, the excellent database systems that Hexagon already has in place. We add that to the automation layer, just a simple layer of technology that goes in between the two, to do decision making and control of the drill. The control of that drill is actually controlled by an onboard integrated artificial intelligence engine. It's not done using Boolean technology like it was done in the past. It's done differently, very, very differently. So we're just mimicking the joystick on the newer machines, so we can plug into the CAN bus on board a drill and essentially control the machine through the existing control network, or we replace the joysticks by bypassing those on older machines. Very simple solution. So what did it do? How did it perform? Well, over a 4-month period, pretty good. Not bad at all. See, the operator on the left-hand side, this data was collected using CAT terrain. At the mine site where we did this, that was their fleet management system, so we used the existing fleet management system to be able to compare apples to apples. We created an operator called Autonomous, and every time the machine was running in automated mode, he logged in as Autonomous, and then the rest of the time, the drillers used their regular logins, and that data was captured down the chart. The autonomous drill, there were two main pieces of data that we were looking at. The DROP, that's CAT's definition for instantaneous rate of penetration. It tells you how good your algorithm or your driller is at breaking the ground underneath the drill bit. So the higher the number there, the better the machine or the operator is at actually using his machine effectively to break the ground. And then the second number was effective rate of penetration, or EROP. That number tells you how productive your drill actually is. It takes into account time spent leveling, time spent drilling, time spent moving from one hole to the next. So increasing that number actually increases productivity of the drill. You can see the autonomous drill had a DROP of 236 feet per hour. The next best operator was 193, and then everybody else was in the 150 range. Effectively, we nearly doubled the production of that drill in terms of instantaneous rate of penetration. The effective rate of penetration, we were 173 and everybody else is in the 130, 120. So we're getting another hole every hour that drill is operating, at least one more hole. It's pretty good. And then at the same time, we actually reduced machine stress by 40%, increased bit life, 24% reduction in cost of drilling in terms of cost per foot, and an overall increase in productivity of 30%. So I leave you with this. It's a quick talk, and I'll take questions afterwards. The data is clear. The system adds value. That came from our site champion that we had to impress in order to get their buy-in, and that's what he said. So with that, does anybody have any questions that I could answer? The underground space, personally, that's not my space, but there is applications that we can apply underground as well. The return on investment you saw right there is about $350,000 US per year in measurable value. In terms of cost, reduction in drilling, reduction of cost of drilling per foot, a measurable value of $350,000 US. There are a lot of other values that are added to that, like the value of good, clean data. When it's running in autonomous mode, you get perfect data. It's not corrupted by man. So it's perfect data. So that data then becomes valuable downstream. You can blast better, you get better throughput in your milling operations. There's a ton of value created downstream by using that. Yes, sir. One. Just one, yeah. We had two. If they shut it down, we have one. Right. So we have one here at Hexagon. I myself have done hundreds of these all over the world in the past. But Hexagon's got one right now running. More questions? Sorry, sir. Oh, how much of the process is automated? It can be automated all the way up to removing the operator and making it fully autonomous. The results that you saw there were simply keeping the man on the machine and automating only the drill cycle. They manually moved it from one hole to the next. Which oddly enough gives you about 80% of the total value that you can capture in automation for 20% of the cost and effort. Anybody else? All right, I hate awkward silence, so we'll cut it at that. Thank you for your time. I appreciate it.